All right, so we are moving on to indicator 30.2. So I want you to watch the video, pause it where you need to, and uh, do some examples in your 3-ring binders. And then when you're done, you'll be able to click load in the assignment. It'll load the assignment in Kami, and you can either complete the assignment in Kami, or if you're having issues with Kami, or if it's just easier for you, you're more than welcome to do the assignment using paper pencil and then just have it with you on Monday when we get back to school together. All right, so indicator 30.2, we are solving radical equations. So we've solved multiple kinds of equations so far this semester, and every one of the ones that we're going to do today are all going to have a radical sign. And we kind of get lazy and call it a square root sign. And all the ones that we'll be working with in this indicator are actually square roots, but the actual technical name is a radical. So I'll try to use that, but I can't promise I won't say square root sign every so often. All right, so right now I want you to pause the video and I want you to write these 3 steps down. And you don't necessarily have to write that reminder in there. That's just there so that you see it. If you want to put it in your notes, you can. But the main thing is step 1, isolate the radical on one side of the equation. Isolate just means get it by itself. So you're going to get the radical alone on one side of the equation. Then you're going to square both sides of the equation. And then you are going to solve for the variable once your square root signs are all gone, or once your radicals are all gone. So let's do some examples. I've got 6 examples here in your notes, or in the notes, and I made sure to pick examples so that you would have at least one example of every kind that you'll have in your homework. Okay, so let's get started. All right, here's your first example. Like I said, anytime it's a video, you're always welcome to pause the video for a second and get written down what you need to get written down. All right, so step 1 is isolate the radical, or make sure that the radical is by itself on one side or the other on the equal sign. Here, the radical, which when I say the radical, I mean whoops, sorry about that. I mean this. Doesn't matter what's under it. I just mean the radical. Okay, so the radical right now, there's stuff trapped underneath it. We're not going to worry about that right now. But the radical is by itself, meaning that the only thing on the right-hand side of the equation is everything trapped under the radical. And then there's a number on the other side. So the next step was to square both sides. So we square this side and we square this side. Now, when we square 2, right, on the left, 2 squared is simply 4. Now, in that reminder on their notes down on the steps, I said, remember that when you square a square root, they cancel out, and what's trapped underneath is just by itself. So when you square a square root, they cancel out, and what's left is the a plus 3 all out by itself, right? The square makes that radical go away, and then what's left on the right-hand side is just simply the a plus 3, or whatever's under the radical. Now it's just a simple equation of getting a by itself. So we know that we want to do minus 3 and minus 3. And when you do that, your 3 and your negative 3 cancel out, leaving a, and 4 minus 3 is 1. So in this instance, 1, or a equals 1. Now, if you want to test this, plug 1 back in for a. So if we plug 1 back in for a, we get a, which is 1. 1 plus 3 is 4. And what's the square root of 4? It's 2. So it checks out. Okay? All right, so now we're going to look at an example like this. Now, remember, step 1 is to get the radical by itself. And again, just as a reminder, this right here is the radical. Doesn't matter what's trapped underneath it, but that's what I mean when I say get the radical by itself. That whole unit together is the radical, okay? So what do we need to do to get the radical by itself? Well, right now there's a 9 attached to it with multiplication, and we know the opposite of multiplication is division. So I'm going to divide this side by 9, and I'm going to divide this side by 9, because in math, whatever you do to one side, you do to the other. Now, the 9 and the 9 cancel out, leaving, now the radical's still there because we haven't squared anything yet. So the radical stays just like it is as a unit over there. The only thing we did was divide off the 9. And then 18 divided by 9 is 2. That is step 1. That is isolating the radical, or getting the radical by itself. We got that 9 off of there. Now is the step where we square both sides. And again, 2 squared is 4. And again, the square and the square root cancel each other out, leaving r over 2. Okay, whatever was under the radical gets freed up and is now by itself on that side of the equation without a radical sign. Well, now we just have to solve for r. Well, r is attached to this 2 with division, right? And so if we multiply, I'll do it in red here. If we multiply by 2 over 1, or 2, and we multiply this side by 2 over 1, or 2, then what happens? The 2 down here and the 2 up here cancel out, leaving the r all by itself. And if we multiply 2 times 4, we get 8. So r equals 8. And again, if you want to test that, you can do 18 equals 9 times r, which is 8 divided by 2. Well, 8 divided by 2 is 4. And 9 times the square root of 4, well, the square root of 4 is 2. And so 18 equals 18. So it checks out. You don't have to check them all if you don't want to. If you're pretty confident in your math, then you don't have to do the little checking part, but it's just kind of nice to verify that what you did is right. All right, so this one I'm going to kind of move through quick because it's very much like the one we just did. Look at your side with the radical and ask yourself, what is on the outside of the radical that I need to get rid of or I need to move? Well, the answer is this 8 times the radical. Well, the opposite of multiplication is division. So I'm going to divide both sides by 8. And when I do that, that goes away. And n plus 2 is left over here. Remember, still under the radical because I haven't done the step where I square both sides. I'm just simply doing step 1, which is isolating my radical. 80 divided by 8 is 10. Now I have my radical all by itself on the left this time. So now I'm going to square both sides. And when I square a square root, they cancel out. And so my n plus 2 pops out all by itself. And when I square 10, I get 100. And then my last step is getting n by itself. So I'm going to subtract 2 and subtract 2. And I get n equals 98. And so that's your final answer. Okay? As long as you do it, step 1, step 2, step 3, you're good. If you want to test it, we can do 8 times the square root of n plus 2, which is 100. N plus 2 is 100, equals 80. 8 times the square root of 100 is 10, equals 80. 8 times 10 is 80, equals 80. So it checks out. Okay? All right, so what do you do when you've got something kind of tacked on at the side with addition or subtraction? Well, you don't do it any different. You still look at this is your radical, and that's what you want to isolate. And you ask yourself, what's attached and how's it attached? Well, that minus 6 is kind of dangling out there. So I'm going to do plus 6 and plus 6. And I do that because I want to get that negative 6 off of there. Erase that. And so when I add 6 to both sides, I get negative 6 plus 6 is 0. And then on this side, I'm left with this and this goes away. And so I'm left with r minus 5. And remember, right, my radical in this step didn't go away because I haven't squared both sides yet. Step 1 is just isolating the radical. And now I'm going to square both sides. And when I square 0, that just means 0 times 0, which is still 0. And when I square a square root, what's underneath it pops out free. And then the last step is to solve for r. So I'm going to plus 5 and plus 5. And so my final answer is 0 plus 5 is 5. And minus 5 and plus 5 go away, and I'm left with r. And again, if we want to test it, negative 6 equals the square root of r minus 5, and in this case, r is a 5. So 5 minus 5 is 0, minus 6. The square root of 0 is 0, so 0 minus 6, and minus 6 equals minus 6, so it checks out. All right, if you ever need to, of course, you can pause these videos, go back, watch what I did. All right, so this is an example of when you have a radical on both sides. These are actually, I think, a little bit easier than the other ones, but not by much because you still follow the same steps. One is make sure the radical is by itself. Well, in this case, you just have a radical equals a radical. So this radical is all by itself. This radical is all by itself. So you can kind of skip one on these. You can skip step one on the ones where you have a radical equals a radical. So that's why I say they're kind of easier, because you can skip step one. You can go right to the step where you square both sides. And that just means that this square makes this square go away, and you're just write it just like it was under the radical, but just without a radical sign. And then this one and this one goes away, so you just write what was under the radical, just like it was, okay? And now you have to solve for the variable. So in this case, we want to get rid of this right here, this 2 on the bottom. So the way I'm going to do that is I'm going to multiply by 2 over 1, because we always get rid of a fraction by multiplying by the denominator. Now, when I do that to that side, I have to do it to this whole side over here. Okay, so you're going to use a little distribution here. But the 2 and the 2 cancel out, leaving the x over here. And now you have to distribute, because when you do something in math, you got to do it to everybody. So when you do it to the one on the left, you have to do it to the right side, but you have to do it to both things on the right side. So I have to multiply everything on the right side by 2. So that means 2 times 2x, which is 4x, and then 2 times negative 21, which is negative 42. And now this is just solving for an equation, okay? I'm going to move my x's all over to the left. So that means I'm going to do minus 4x and minus 4x. And in this step, I'm just simply getting all my x's over on the left. And when I do that, 1x, right, because that's really a 1, 1x minus 4x is negative 3x. And then those cancel out, equals negative 42. And then the last step is to divide by negative 3 and divide by negative 3. And you get x, oops, let's do it in black. You get x equals, and then negative 42 divided by a negative 3. Well, you have 2 negatives, so you know your answer is going to be positive, and 42 divided by 13 is 14. Or, sorry, 42 divided by 3 is 14. Now, if we check our answer, we're just going to plug a 14 everywhere where there was an x in our original equation. So we have the square root of 14 divided by 2 equals the square root of 2 times 14, 2 times 14 minus 21. So 14 divided by 2 is the square root of 7, and 2 times 14 is 28 minus 21, and that's all still happening under the radical. And so the square root of 7 equals the square root of 28 minus 21 is 7. So the square root of 7 equals the square root of 7, so it checks out. So with these, they're easier in that you do not have to worry about step 1, but they're a little bit harder when you have to especially when you're dealing with a fraction. You've got to remember, the main thing you got to remember is that when you multiply this side right here by 2, you have to multiply this whole side by 2, and that's where that distribution comes in. Okay? And then it's just a matter of moving all your x's over and solving, and you guys should be pretty proficient in solving for basic equations. All right, last example, and we are going to square both sides. This one will be a little bit easier because there's no fraction. And again, right, when I square a square root, it just means everything under the radical pops free. And when I square this side, everything under the radical pops free. And now I'm going to move all of my variables to one side and all of my numbers to another. And it doesn't really matter which way you do it because you're going to get the same answer either way. I'm going to go ahead and move all my variables over to the left, but if you want to do it different, it will not matter. And I'll actually show you at the end of the video how it doesn't matter. So in this case, I'm going to do minus 3n and minus 3n. And I'll do this in multiple steps so I don't lose anybody. So we've got 16. Negative 2n minus 3n is negative 5n. Those go away, and I'm left with negative 14. Then I'm going to subtract 16 and subtract 16. And that leaves me with negative 5n equals negative 30. And I'm going to divide by a negative 5 and divide by a negative 5. And that leaves me with n equals negative divided by a negative goes positive. 30 divided by 5 is 6. So I get n equals 6. Now, I want to show you something. I want to show you from this step right here, okay, right here. If I had decided to go the other way, whoops. So 16 minus 2n, sorry, my handwriting's getting bad, and then 3n minus 14. So I'm just rewriting this step right here just because I want to show you that what if I had taken my variables over to the other side. So what if I had gone plus 2n, because that's a negative 2n, and plus 2n. And that would have left me with 16 equals, that's gone. 3n plus 2n is 5n. And then minus 14 just drops down. And then I would have added 14 to both sides. And when I add 14 to both sides, I get 5n equals, well, 16 plus 14 is 30. And now I would divide by 5 and divide by 5. And I get n equals positive 30 divided by positive 5. Oops. Equals, put the equals on the wrong side. Sorry about that. Positive 30 divided by positive 5 equals a positive 6. So here I got n equals 6. Here I got n equals 6. So it didn't matter if you decided to move your variables to the left or to the right. As long as you use the proper plus and minus and you move all the variables to one side and all the numbers to the other, you'll eventually get to the right answer. Okay? All right, so now that you're done with the video, you should have 6 examples in your notes. Just as a reminder, anytime I do a video and I tell you to take notes in your 3-ring binder, there's usually a note check the next day at school. So, hint, hint, make sure you have 6 examples in your 3-ring binder on Monday, just in case I do a note check, okay? You are ready to click load at the bottom of your, go back to Canvas and click load up the assignment in Kami. And again, you can either do your assignment in Kami just like I did it right here, or you can do it on paper and have it ready with you on Monday when we all get back together in class. Please email me if you have any questions, and then I am going to open a Google meeting at the beginning of each one of my algebra classes on Friday so that you can ask me questions. So I'm going to wait about 15 minutes into class to give you a chance to listen or to watch this video. And then I'll open up a Google meeting so that you can start working on your homework. And if you have a question, you can pop over into the Google meeting and ask me a question just like if we were in class together. Okay? So then email me if you have any questions. Pop into the Google meeting if it's during class time if you have any questions. And I will see you all back in class on Monday. Have a great Friday and have a great weekend.